Okay, you have now become masters at drawing these pretty pictures. You've drawn plus signs, you've drawn minus signs, you've even drawn some heaps and holes, and you've drawn those number lines, and you've drawn arrows left and right, and life was good. Now we're going to get into the part that students don't really like, but it's a really useful thing when you get problems with larger digits, with larger numbers. Because you guys should know by this point that in 7th grade, when we're adding and subtracting positive and negative numbers, we're not dealing with -2, +1. We're going to be dealing with numbers in the 20s, in the 30s, -157. And I don't know about you, but I personally do not want to have to spend my time drawing all 157 positives or negatives, and then drawing another 212 positives or negatives. That's a waste of my time. It's a waste of my paper. And I don't want to do that, and I'm pretty sure that most of y'all don't want to do that as well, unless you're just dying to waste time, in which you shouldn't be. So when it comes to justifying integer addition, or justifying in general, it means you're going to be writing more sentences than you are doing the actual math. The thing to remember for this is that it will only work with 2 numbers. Anytime you're given a problem and it's got more than 2 numbers, you can't go about it this way. You're going to have to break it down and to deal with 2 numbers at a time. So starting with the first one, we have to note that we have these lovely little rules up top, and these rules are important. These rules are going to be what you live and breathe and think about and dream about and just are the greatest things in the world for the rest of this school year. Got it? So if you can master these now, I promise you life is going to be a lot easier on you the rest of the school year. Taking a look at this, we have to note that that both of the rules here state if the signs are the same or the signs are different, meaning you're looking, are both numbers positive? Are they both negative, or do you have one of each? That's going to be what determines what the justification or what the steps are going to be. So let's take a look at the first problem, 4 plus 6. You all are smart. You're very intelligent. You don't need to worry about 4 plus 6 and knowing that it's 10, because you guys already know that. The thing about that is, in order to try and understand this justification piece and thought process, is that we need to use a problem that you guys already know the answer to. So when it comes to justifying, it's mainly putting your thought process into words. It's thinking about what are the questions that I'm asking myself, and I'm writing the answers to them to help me with thinking through the problem. Starting with 4 plus 6, we look at it and we go, all right, 4 and 6. Those numbers have the same sign. We note that the signs are the same. We note that the signs are the same, that they're positive. So then we look up at the top at the rules and we see, hey, if the signs are the same, we're going to add. So we add 4 plus 6 and we get 10. And then it says keep the same sign. In this case, positive. So we end up keeping the same sign positive. Therefore, 4 plus 6 is going to be positive 10. Those are the steps, the process that you need to be writing when you are solving these. Don't take shortcuts. Okay? Shortcuts are going to lead you to frustration because they may not work every time, or you're going to get confused. I know it's really easy for me to be writing these because I get to type and you don't. However, I've done this a few times, been doing this a few years, so I get the luxury of being able to type it. Let's take a look at the second one. We have -4 plus 6. So we note that in this case, the signs are different. That's a big deal. The first one, the signs are the same. It was super easy. This one, the signs are different. So we note that if the signs are different, we have to subtract. When we subtract, we want to do subtraction with the larger number first. So we say 6 minus 4. Or instead of larger number, the larger absolute value. 6 minus 4, we know 6 minus 4 is 2. Pretty straightforward. Then it says to take the sign of the larger absolute value. So the larger sign is, look at the problem. 4 negatives, 6 positives. 6 is we're gonna have more positives. If I drew this out, I'd have more positives. So we end up with the larger sign is positive. Therefore, when we go to solve this problem, we say, we know that 6 minus 4 is 2. We have more positives. The larger sign is positive. So it's -2. If you prefer to think of it instead of larger sign is positive, you can think of it as more positive, that's fine. Both of them mean the same thing, and get the idea across that you understand that it has to be positive because there's more positive. The larger absolute value is positive. Let's go down to the next two examples. 4 plus negative 6. Well, we look at it and we say, okay, are our signs the same or different? In this case, we have signs are different. So that tells us we're going to have to subtract. So we subtract like we normally would. 6 minus 4 equals 2. Well, that looks exactly the same as the last one so far, right? 6 minus 4 is 2, 6 minus 4 is 2. So even though there was the different number was negative, we still ended up subtracting because the two signs were different. Now we can think of it as larger sign is negative, or you can think of it as more negative, whichever you prefer. You do not need to write both of those last two steps. They mean the same thing. I'm just trying to give you two different ways to put it. And the way we know that it's negative is because you have 4 positives, 6 negatives. You have more negatives. And therefore our answer in this case would be negative 2. Because we had, when we subtracted, we ended up with 2, and we ended up with more negatives. If you were to draw it out, 4 pluses, 6 negatives. We know that all of those equal 0, and look, negative 2. So that's the way it works, kind of relating it back to the modeling. But again, with larger numbers, you don't want to have to model it. It's a lot quicker and easier to go through and write the rules out. Now let's take a look at the last example. Negative 4 plus negative 6. We note that the signs are the same. They are both negative. So we know that means we're going to have to add 4 plus 6 equals 10. And now we keep the same sign, which in this case is negative. So the answer we end up with is negative 10. When we take a look at it, we note that it's kind of the same as the first one, except this time with them both being negative, it's going to be negative. To relate it back to modeling, 4 negatives plus 6 negatives. Notice there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negatives, negative 10. That is how you justify integer addition.